notes. It looks like this. Over what main topic?
Weather and climate.
Weather and climate, okay? And we should know, it's really important to know or understand the difference between the two. They're obviously related, okay? But the difference is what?
Climate is over a long period of time, and weather is the exact, minute by minute.
Yeah. And what's happening to weather on a daily basis?
Rain,
It's changing constantly. Like tomorrow, it's going to start off real nice, and then later tomorrow, it's going to get all stormy and whatnot. It's supposed to. So we'll see. All right. So we are also taking a look at the different factors that create the different types of weather and climates. And the first one we looked at was what?
Sun.
Yeah. So how much direct energy or indirect energy a location is getting, and that's all because of what?
I have no idea.
The solar.
Oh, this is a tilt. Okay. And because of the tilt, the equator is getting the most direct energy. So it's getting the most warmth. All right. And then because the poles are not getting much direct energy at all, it's where it's really cold. So you're getting extremes at the beginning or at the equator and at the poles. Okay. And then you get your middle latitudes. What else is being affected by the sun's energy? I'll just say it.
Season.
Water.
Yeah, the water and wind. Okay.
Wait, how does I forgot. How does the wind affect the?
Isn't that what the notes are?
I mean, how does the sun affect the? I know.
So the sun is heating up the air
Oh.
and it's heating up the water.
I remember.
And then there's that cycle of heating and cooling, right? So I think that's kind of where we left off. We talked about wind is just a sideways movement of air, and as it's being heated, it rises up, and then because it's getting to the atmosphere where there's not a lot of heat, it cools down and sinks. But it's not just going up and down,
It's
circular.
moving.
Yes.
It's on an axis.
Well, and that's because the Earth is rotating. Right. Did anybody, I think in the other class, someone wanted to know how fast the Earth was rotating.
No, that was
Really fast.
It was really fast. Okay. All right.
But the second is I asked how fast are cars. I wrote that down.
How fast are cars?
How fast are cars?
So today, we talked about the air, but then we started talking about ocean currents, and they're going to act similarly to like air currents. Okay. So where do you think the water is the warmest?
Near the equator.
Yeah.
Yeah.
So, yeah, absolutely. So what page are we on?
53.
52 or 53, I hear. And so there's a really good diagram on page 52 of where the warm and cool currents of the ocean are. So we're on page 52, Brandon, okay? So obviously the red arrows are where it's the warmest, but it also tells you the direction of the currents, okay?
There's some cold mixing with warm everywhere.
Yeah, but that's because it's circulating down to the poles and getting cold, and as it's being pushed up, then it's getting warmer towards the equator. Okay? And they're not all going in the same direction, are they?
No.
No. All right. So we got as far as ocean currents are large streams of surface water. Who was reading or who would like to read today? Dixon? I'll get you.
Where do you want to start?
Just start at ocean currents.
Like wind, ocean currents, large streams of surface water move heat around Earth. Wind drives these currents. The map above shows how Earth's ocean currents carry warm or cold water to different areas. The water's temperature affects air temperature near. Warm currents raise temperatures. Cold currents lower them. The Gulf Stream is a warm current that flows north along the U.S. East Coast. It then flows east across the Atlantic to become the North Atlantic Drift. As a warm current flows along northwestern Europe, it heats the air. Westerlies blow the warmed air across Europe. This process makes Europe warmer than it otherwise would be.
Okay. So we wrote down the definition yesterday, I believe. And then I also added wind drives the currents. Okay. So you're going to find the fastest currents at more at the surface of the water rather than at the bottom of the ocean.
Is there any wind down there? Because wouldn't there be like gases and stuff because the whole soup vents?
In some locations, sure, where those vents are. Yeah.
So it's just boiling.
In some places, but some places it's not because the direct energy is not going as far as it can in the ocean there.
At the bottom of the ocean floor, since it's so cold and there's a bunch of pressure, is there ice?
Oh, I'm gonna slip and
Is there
fall
ice
in
at the bottom of the ocean?
There's-
I don't know.
I'm gonna slip and fall in the
Good
water.
question, but I don't know. I actually
It's
do not know that
compacted.
one. All right. So what is one example of a current? It actually has a name.
Oh,
You just read it.
yeah,
Which one?
the Gulf Stream.
Yeah.
The ocean.
So an example is the Gulf Stream.
I'm alright.
So, and this is a really interesting example because the Gulf Stream is coming from the Gulf of Mexico where it's warmed up and it's being pushed up to like Great Britain area and Northern Europe. And if you look at the latitudes so if we're looking at our map here, the latitudes here of where Great Britain is up by Canada. Now, what do you know about how cold or hot Canada is?
It's very, very cold.
It's very cold, okay? Especially up the top, okay? And if it's the same latitude here as Great Britain, you would think it's the same temperature, but it's not. It's actually quite mild, and it's because of this Gulf Stream, okay? So it's actually regulating the temperature to be a lot milder because of the heat that it's pushing up this way. So it's really
always rainy there.
And it's not always, but it is
Yeah, a lot.
more often for sure.
What about Ireland? This isn't very rainy.
Ireland,
Yes.
yeah, because Ireland is west of Great Britain, so it's going to experience it, and it's right next to the ocean, so it's going to be the air is going to be carrying a lot of moisture, anyways. So that's where they're getting a lot of the rain from.
Imagine being in so small of a country and owning like half the world.
And they did. I mean, Great Britain did. So I wanted to show you something really cool. We'll come back to the notes in just a second. But in Moodle, I found, not in Moodle, but I put it in Moodle. I found this should be it right here.
Little map thing.
An interactive global map of wind and water currents. Like it's active, like showing real time stuff. So I'll make it
Have a
bigger.
giant thermometer on there.
Yeah. So, and you can look at it on Moodle too, but it's showing you right now the direction the currents are moving. I don't know. Can you see that?
Yeah.
And that's just on one side of the earth. But you can,
Rotated.
yeah.
Maybe that's why it's so windy today. Because they're all moving in different directions.
All right. So the wind, it looks like,
The
right
pole,
here.
There's a circulation. Okay.
so there is circulation, and that's
Like towards the pole, there's the
up here as well. Yeah, do you see it?
cold and then colder air is mixing together in a spiral pattern.
Yeah, that's really cool. It's the center of low pressure, low pressure, low pressure, low pressure.
Yeah,
Okay.
Where is low pressure? Like where it's the coldest or the border of warm?
It doesn't matter. So here's some low pressure right here
You
too.
can see over there in the yellow and the green over there, it's like swirling up in there.
Over here.
Yeah.
It's like
Yeah.
a weird glass ball.
I want one.
So that's
now.
cool. And then you can manipulate it. Let's see. Let's look over here in Africa.
Let's
And
look at Brazil.
You are going to.
and get a chance to.
That was second class.
So I mean, that's really cool. So you can see where all the direct energy, solar energy, is located, and the indirect as well. So at Arctic and then at the Antarctic here. But then over here at the bottom, you can manipulate it, and you can go. So that's air mode, and then you can go ocean mode.
Yes, ocean.
Water.
Water.
So now you can see. Oh,
Water.
cool. So here's that Gulf Stream, and you can actually see it. Okay.
Where's
there's
that
hot
giant
spots.
red volcano?
Giant red volcano.
A giant red dot in the middle.
Like this? I don't know what that is. But you can see the,
Hurricane.
What are the other ones?
I don't know. I just know the Gulf Stream because we live closest to it.
No, I mean like what are the other like ocean ones?
Isn't there like some kind of
Hey, look, Hawaii.
ocean currents
Hoo-wee-wee.
No.
in Australia that like drags you down?
Oh, I don't know about that, but it's the East Australian Current, and the only reason I know about that is from what movie?
I don't know.
Finding
Nemo.
Nemo.
Huh?
Yeah.
Oh no, not because of Nemo. I just it's water.
I think that so. The East Australian Current is over here somewhere.
Hey, look at Australia. I love.
So really cool. You should check it out.
Story was good.
But what?
So animate
if you go
the
to
waves. So
air
these are the waves. And I guess these are the currents. I had it on waves.
Scale.
Okay, cool. That's so cool.
Alright, so I figured out what the red things are,
What?
and apparently that's real big.
Yeah, that is.
It's ginormous.
Don't say.
What's
Yeah.
that?
Okay, look. There's the current. There's like the. Oh, there it is. So
Looks
cool.
like a very large wave.
No,
That's
it
Can I
says
zoom
scale.
in? Oh, I can zoom in. Sweet.
traveling in a weird direction.
Yeah, zoom in on that red dot.
Love.
That looks like if you turn to a peach.
Whoa, that's so cool. Look at that.
It's like all around Florida.
It's like big clouds.
Yes, it went around the floor.
That's pretty. That's really cool, y'all. I need to
It's
watch
like
this
that
all
one
day.
painting where a dude rolled a bike over it and then let it go.
That looks like the was it
Starry, Starry Night?
Mango?
Yep. All right, and then
Or coffee.
so you can see up here. Then
I
the
mean, it's creamer.
Gulf Stream is going up this way. All right. Anyway, that's something that you can take a look at and then manipulate the variables over here.
Right there, it says scale.
But it
That means it's real big.
if you go to the air currents or the air
Yeah.
around like Michigan and stuff, for some reason there's I think it was there's some weird spot or I don't know if
There's
that's
Michigan
the
right
Great
here.
Lakes or
So it
not.
happens in 2020.
Like it was I don't know how.
Where are the Finger Lakes?
Looks like the whole world is water now.
It's so cool. Anyway,
No, it's all
Big
water.
Ten.
so I bet if you check this out that there's an actual storm over here brewing, going that way, going east.
Oh no, watch out, Russia. Oh no, that's not Russia, that's
That's
Europe.
Europe.
That's
Watch out, Europe. You're about
All right.
to
So
go.
anyway, there's that. I just want to make sure you saw that. Yeah. Okay.
That's cool.
Very cool. Available to you to take a look at. Now we're gonna go back to this.
I'll just play with it tomorrow.
Well, you can.
I'm not really doing anything else.
Are you gonna come on? There it goes. Okay.
Oh yeah, I'll look inside there.
All right. So let's talk large bodies of water. Obviously, the ocean is a large body of water, and it can actually have an effect on the climate where the currents are located. Okay. So, Jackson, you want to read that for us? Where it says large bodies of water.
53.
Yeah,
Yeah.
I know, but like, does it go into the tornado?
No, it just goes down.
Large bodies of water, such as an ocean or sea, also affect climate. Water heats and cools more slowly than land does. For this reason, large bodies of water make the
temperature.
temperature of the land nearby milder. Thus, coastal areas such as California coast usually do not have as wide temperature ranges as in island areas. Inland areas. As an example, the state of Michigan is largely surrounded by the Great Lakes. The lakes make temperatures in the state milder than other places far north.
Okay, so what do you think we should write here? There's not a whole lot to write, but it's pretty
Does it
significant.
affect the climate?
So large bodies of water affect the climate. So then someone's gonna ask how.
Oh.
How does it affect the climate?
Water heats and cools more slowly.
That's it. So H2O heats and cools more slowly. A good example of this is, I remember in my ninth grade physical science class, or 10th grade, I don't remember. He started heating up some water in a jar, and then he started heating up metal. And he asked me, which one would I rather touch? And I picked the water because I inherently knew that it takes a really long time to heat up water. It does not take a long time to heat up metal.
He's
Right?
hot.
So
Both of them. But
they will, but it takes longer for the water to heat. Okay?
So whenever you're waiting for a pot to boil, it looks like it takes a long time.
Forever,
Man.
right? But you can touch the water in the pot, but you don't want it to actually touch the pot, right? Because you know that the
You don't
outside
want
is
to
gonna
touch
be
it when it gets really
Sure.
boiling.
I did too.
So what's happening is the water, and the great example is the Great Lakes. If it heats up, it's actually going to keep the land near it heated up, or at least warmer. If it cools down,
I don't think that's nice of a trade-off since the storms.
right.
Yeah.
But it's not gonna be as extreme. The weather is not gonna be extreme around where the Great Lakes are because of the property of water heating and cooling more slowly.
When electricity
What happens since the Great Lakes are warm? What happens whenever cold currents come?
Well, they'll come, okay, but it'll take a lot longer for the temperature to decrease. I don't know.
I'm talking about the storms.
The storms. Well, the storms are going to have effect on the water, and again, that water is going to regulate the temperature that's just around the coastline of that land. Okay, so it might be a good spot to settle
For beavers.
for beavers. Beavers, yeah, they'll be fine.
I was talking about the public school beavers.
Well, okay. All right, so we got large bodies of H2O or water. So I'm going to put like oceans and large lakes, just so we know what we're talking about there. Okay. Yes, sir.
Can I read the next one?
Absolutely. What do we got? Wind, water, and storms.
Alright. If you watch weather reports, you will hear about storms moving across the United States. Tracking storms is important to us because the United States has so many of them. As you will see, some areas of the world have more storms than others do. Most storms occur when two air masses collide. An air mass is a large body of air. The place where two air masses of different temperature and moisture content meet is a front. Cold air masses from the north and warm air masses from the south frequently collide over the United States, producing dramatic storms. Fronts can produce rain or snow as well as severe weather such as thunderstorms and icy blizzards. Thunderstorms produce rain, lightning, and thunder. In the United States, they are most common in spring and summer. Blizzards produce strong winds and large amounts of snow and are most common during the winter. Thunderstorms and blizzards can also produce tornadoes, another type of severe storm. A tornado is a small, rapidly twisting funnel of air that touches the ground. Tornadoes usually affect a limited area and only last a few minutes. However, they can be highly destructive, uprooting trees and tossing large vehicles through the air. Tornadoes can be extremely deadly, as well as in as well. I was wrong. In 1945, a tornado that crossed Missouri, Illinois, and Indiana left 695 people dead. It is the deadliest U.S. tornado on record. The largest and most destructive storms, however, are hurricanes. These large rotating storms move over tropical waters in the Atlantic Ocean. Atlantic Ocean, usually from the late summer to fall. Did you know that hurricanes and typhoons are the same? Typhoons are just hurricanes that form in the Atlantic Ocean. Bless you.
Okay, so I wrote a couple things down here.
Messed that up a little.
Did you get it all?
Yeah.
Yeah.
I messed it up a little.
No, it's all good. You got it. So we're really talking about storms and how they form. And it's when two air masses collide, usually a hot and wet air mass with a cold and dry air mass. And those create some type of storms. That could be a thunderstorm with rain, or it could cause blizzards as well. Depending on the right conditions, you can get a tornado. We've already talked about that because we live in Tornado Alley. Okay, so we're getting warm, wet air from the Gulf of Mexico and cool, dry air from the west over the Rockies. Yep. Okay. So because they're so extreme, for some reason that creates a vortex of air, which creates tornadoes. So hurricanes are more destructive because they can gather much more energy from the ocean currents.
I
Yes.
have a question. You know how lightning and water do not mix well?
Uh-huh.
When it's thunderstorming, it's kind of not great because there's water and also lightning.
Uh-huh. It's bad. Bad combo.
Would that like do anything?
No, because if there's no electric current, then there's no electric water. So.
So do hurricanes like last a lot longer than tornadoes?
Yeah.
Because like tornadoes.
That's why tornadoes
Hurricanes
just
are
go
few
overnight, but hurricanes usually last like 3 or 4 days.
Yes. So and you can track them. And again, my husband should be coming in here to teach this, but he loves to watch the airplanes. There's a specific type of airplane that can go into the eye of the hurricane and take measurements and
And
stuff.
it goes inside of it.
Yeah.
That was cool.
Yeah. That's crazy stuff.
I mean, just be peaceful in there.
Yeah, because it's pretty calm in the eye, as opposed to on the outside. So typhoons is another thing that you need to know about. They're the same thing as hurricanes. They're just located in the Pacific Ocean.
Wouldn't they also be worse since the Pacific Ocean is warmer and all that?
I usually don't think of the Pacific being warmer. I think of it being cooler, actually.
Well, you
But
said this one reminded me of the
don't know.
movie Into the Storm because they try to go like inside the eye of the storm. And stuff.
Yeah.
I watched that like long time ago.
oh, I didn't tell you this. I watched a movie over the weekend called The Impossible, and it was about an earthquake happening. This is a true story. Off the coast of Thailand, and the tsunami that it created. Wow, it was intense, man. You should totally watch it. It's called The Impossible. It's forget what it's on. It's on Netflix. It was on Netflix.
There's this one like port city, but it was on like quicksand, and like a earthquake happened like 3 miles or farther from it, but the vibrations made all that quicksand
Just
swallow.
yeah.
Can you dig up?
All right. So let's turn the page because we're about done here. It talks about hurricanes. I'll finish this out. I'll finish the hurricane part out, and then I'll ask someone to do mountains. It says hurricanes produce drenching rain and strong winds that can reach speeds of 155 miles per hour or more. This depends on what the category is. The higher the category, the faster the wind speed. This is more than twice as fast as most people drive on highways. In addition, hurricanes from tall walls of water called storm surges. When a storm surge smashes into land, it can wipe out an entire coastal area. Both. I mean, that's what they both are.
Wait,
Well, the storm surge is water from the actual storm that's being produced by the storm, but the tsunami is basically the sucked out wave coming back in at full force because of the earthquake. Okay. Yes, sir.
So it's like a cloudburst, like quake rain, like a quake storm.
No, it's a combination of the rain and the waves coming in. The storm surge. Is that what you're talking about?
It made the height of the waves like waves.
Yeah.
Over the land with enough energy to go over the land.
Yeah.
It's like a small tsunami.
Not good. Not good. All right. The last thing that affects weather and climate are mountains. Who would like to read about the mountains? Ellie, saw your hand first.
Mountains can influence an area's climate by affecting both temperature and precipitation. Many high mountains are located in warm areas yet have snow at the top all year. How can this be? The reason is that temperature decreases with elevation, the height on Earth's surface above sea level. Mountains also create wet and dry areas. Look at the diagram at left. A mountain forces air blowing against it to rise. As it rises, the air cools and precipitation falls as rain or snow. Thus, the side of the mountain facing the wind is often green and lush. However, little moisture remains for the other side. This effect creates a rain shadow, a dry area on the mountainside facing away from the direction of the wind.
Okay, so instead of writing words, and I've written some words, I'm actually drawing a little diagram. So, so it could be hot down here and cold up here. Okay. And that's because as you go higher in altitude, the colder it gets. So for like every, for every 1,000 feet, it drops 4 degrees. I believe that's correct. I've heard maybe 3. So this is your altitude. Altitude. So you can be in Hawaii
Have snow.
and have snow. Yeah.
Actually, that wouldn't happen with it because the tall mountains are usually volcanoes.
But as you saw Mount St. Helens, it had snow as well. Okay.
But I don't think any videos or pictures of it before it exploded had snow on them, unless it did.
All right.
I think it did.
So on one side of a mountain is going to get a lot of the wind. Okay. And the air is being pushed by the wind, and it's going to hit the side of the mountain basically and force the air up. Okay. But as it's hitting that, the mountain is actually an obstacle for that air to come over here. So on this side, you get what Ellie read was a rain shadow, meaning it doesn't get any rain. This is also called the leeward side. So it can be really green around here on the windward side, and then you can get a desert on, did I spell desert right? Yeah. So it can be on this side, you're going to get a lot of moisture and humidity. No, with moisture. But over here, it's going to be really dry. Okay. I know there's a lot of words. You can draw it however you want to. But a really great example of this is when I went to Washington State when I was in 7th grade, actually, over the summer. We were on the rain shadow side of Washington State. Washington State is the evergreen state. We didn't see much green on our side of Washington State because we were in the rain shadow. If you wanted grass, you needed to water it. But it could get up to 116 degrees but not feel hot. That's because it didn't have any
Wind chill.
moisture.
Humidity.
Exactly.
Wind chill.
Exactly. Not wind chill. Not
I
wind
mean,
chill.
there'd be wind there just
Sure.
from the ocean.
Right.
Yeah.
Okay.
It's not like some parts of Washington State are like Ireland and always rainy.
Yeah, it's kind of weird though. Like, when we fly to Alaska, we go over before, like 30 minutes before we land in Anchorage. We go over like the mountains, and you can see like snow on the top of them. But when we land in Anchorage, it's all like green and I don't know.
And that's probably because of the altitude
yeah.
and the time of year you
Like in the
go.
hallway show.
Well, we went during the
That's
summer.
no one went.
Okay.
Because it's
Where-
been active.
All right. So you can be in a desert climate
And be,
and still have mountains with snow on top.
I mean, you can also be cold in the desert. Very
Yeah, at
cold.
night for sure. Okay.
Time it gets real cold.
So what are our factors in determining weather and climate here then?
Sun and location.
Yep.
Wind currents and all that, and mountains.
Mountains and ocean currents as well. Okay. Those are your factors affecting weather and climate. All right. So I'm going to introduce you to your assignment. I may get enough copies run, but you do have the alternative to do this on Aminote. It's already in Moodle, but I'm going to show you what it looks like here. So this is actually talking about history and using geography to demonstrate some points here. All right. So what do we got? It says before airplanes or steamships, explorers and trade ships sailed the seas, and they're propelled by the prevailing winds. So in 1492, Columbus knew already about the ocean currents and prevailing winds.
But there were also rowboats, very large rowboats.
So Columbus relied on the winds and the currents of the Atlantic and Caribbean on his voyages. And other explorers and traders would too, especially after they document their voyage and which routes they took. So what you're going to be looking at is this map. So you have to look at this very carefully, the key. Okay? So how many voyages did Columbus actually travel?
I think it's
4.
1, 2, 3, 4. Okay? And you'll be able to when you get a copy. All right? So these two arrows here are trade routes. Okay, I didn't do that right. Trade routes. That's what it says. Okay? And your first task is to color the map, but you have to follow the instructions. It says use a bright color to mark wind systems, including trade winds and westerlies on the map. Does it show that anywhere on here where they are? So what are you going to use to find the westerlies?
The
The
trade
guide.
routes.
The
Google.
thing on the side. Dude.
You can do Google. What about your book? Does it have it on there?
No, it was showing the Pacific side
No, look.
of the ocean.
If you look at your book on page 51, and I also put it in Moodle. On page 51, it has your global wind system. Okay? So, is South America on that map? Yeah. Totally is. It's right here. It's right here. Okay?
Yeah, that's on there.
So here's South America. Now this is where a lot of people got confused, and I figured out why. It's because they need to compare this map to this globe. Okay? You're only looking at a certain portion. This is not the whole entire map, of course, of the world, but you need to know where Europe and Spain are, and Great Britain, compared to where North America is. And that does show right here, here are your trade winds and your westerlies. Okay? And you actually need to mark the wind systems, specifically the trade winds and the westerlies on the map. Okay? You think you can figure out where to put them?
Mm-hmm.
Okay. So do it pretty light because you're going to be coloring other things as well. It says use a different color to mark major ocean currents on the map. Same thing. They're not already marked on here. These are not any ocean currents. They're trade routes. So the next page in your book shows
Is on
the ocean currents. You're only going to be looking at this portion right here because that's what all there is on the map. Okay, so that's what you're going to color in or mark the ocean currents.
You have to, does it matter if they're cold or hot or whatever?
It doesn't matter if they're cold or hot, just one color. Okay. And then you're going to get a third color to mark a direct route from Spain to Hispaniola. What does a direct route mean?
Like straight.
Exactly.
Great line.
Okay. All right. So you're not following any of these. Not going to follow that. All right. You're just going to do what this says to do. So the fourth color is going to mark a direct route from North America to Europe. So that's like a straight line. And then use the map legend to reflect the colors that you added to the map. So you could actually just underline this for whatever color you're, like I have colored pencils and you can just underline, that could be your map or legend. Does that make sense?
Bruh.
Reflect. So whatever fourth color is, just underline what color you're going to use. So you're going to have how many different colors?
4.
4. Okay. And you're not marking any of these, okay? Because you're going to compare these routes to the ones that you created.
Oh, okay.
Okay. So once you complete this part, then you have to answer some questions on the back.
Question.
Questions. All right.
I don't.
So you're comparing what you're drawing on there to how he actually did it. Okay.
It's not tomorrow.
No, that's why I'm going over it right now. Okay. It's all good. We have 45 minutes to work on it tomorrow. Needed. So you can either do it on a piece of paper or you can do it digitally on Amanote.
Alright.
Okay. But I'm going to need to make copies of this and I can do it from here, but I'll need someone to go get them. All right. Questions. Maybe you need to have some time to look over it before you have questions. All right. All right, let me stop this.